Howdy, everybody. Hope you're doing well wherever, whenever you are. My computer's not. Today's going to be more of a uh, review than a live coding, mostly because my computer died. Um, right while I was like at the conclusion, I was just kind of like wrapping things up. So that's kind of a bummer. But we'll talk about it more like a review process, and then hopefully I've got my computer things figured out. You know, sometimes I don't know how many people like to work on computers and do their own stuff with them, but sometimes you just have to try different things until you get it to work or whatnot. So anyway, with that, I'll still kind of go through the stuff that I did and everything like that. So what is the problem today for day 21? It's the idea is you're given a password, is just a string of characters. Like this is the password you're given, and they want you to apply a set of rules, and that's going to be your puzzle input. So that's these right here. And they just tell you what you do, right? So it says if you're swapping position X with Y, you just swap those two characters. If you're swapping letters, you find those positions of those two letters and then swap them. If you're rotating left or right, you're like shifting the string around. Anyway, there's a bunch of rules. We'll go over them. And the idea is you just apply those rules to get your scrambled password. Like that's the initial problem for part one. So what does that look like solution wise? Again, I don't think it was too hard. We probably have done things similar to this before, is where, okay, we have a list of instructions. So we're going to create an enum for those, and then we'll write a parser. So I'm just going to, split my white space and then match on the parts. And then I can use the slice matching to like set up their instructions. And so then what I do for part one is basically just, given the password for each of the rules, call apply on the password and then return the last password. I'm using a vec of characters because it seemed easier to like move characters around and stuff like that than iterate on a string. So you see, when I do my applies, I can just use the vector directly, and that was kind of intentional. I don't know all of the things that vectors do because there's like a million of them, it feels like, but I've definitely seen things like rotate left, rotate right. Excuse me. Those are like really efficient ways to move information around. And so that's what I did. Used a vector to leverage like what the standard library already gives you. So like, what are those things that it gives you? One of the rules was swap position. And basically what that is you call vector swap, right? When you're swapping by letters, first you need to find where those letters are, and then you can swap. Rotate left and right are literally just the same. There's functions that do that. If you're not familiar, what they do is like rotate left pulls things off the front and puts them in the back at the end of the vector. So like rotate left 3 takes the first 3 characters, puts them on the end, and the right does the opposite. Take them from the end, put them to the front. Rotate by letter was like the one that's a special rule and becomes particularly hard in part 2. The idea is you find the position of the letter right here, and then you determine how much you want to rotate right based on that position. So you always do 1 plus that position plus an additional 1 if it's greater than or equal to 4. The position is greater than or equal to 4. This one can overflow, right? So you definitely need to do it modulus v.lane, right? Like say the number ends up being like 7, but your size is only 6. You actually want that to wrap around, right? So reverse. This one was probably for part 1 the hardest to implement. Initially I tried like pulling a slice out, iterating over it, reversing it, and then calling splice or something like that. I think that's what it was. I couldn't get it to work though, and it was a borrow checker thing. There's just sometimes the borrow checker, I haven't figured it out yet. So what did I do? I just like kind of did the idea of like start at both ends, switch those letters, move in one, switch those, move in, switch those until you get to the middle, right? And that worked. And then finally move, super easy. So that was it for part one. It's pretty easy. Most of this time is actually parsing. Part one wasn't hard at all. What does part two say? It's like, oh, you know how you scrambled those passwords? I actually want you to unscramble them now. So you're given a scrambled password, and the idea is, given your rules, can you unscramble the password? And this did take a little bit of time for me to like totally get it all correct. Think about what you're doing when you're unscrambling, you're undoing what you've done. Obviously, you're going to do those things in reverse, but not all of them are strictly reversible. So think about these for a second. Swap position, that's easily reversible, right? You just say, oh, I'm just going to, I swapped X and Y, so I'm just going to swap X and Y again. If you swap two letters, you just swap again. That's really easy. Rotate left and rotate right, they're like opposites, or their reverses is just the opposite rotation, right? So if you've rotated left some number, you now rotate right. We'll come back to rotate letter because that was the hardest. Reverse is the same, right? You're still going to take a thing and you're just going to reverse it again. Move is a little trickier because you had to think. This one, you do the opposite of what you've done before. Say you pulled out from position 1 and put it in 3. You now want to do the opposite. You pull out from 3 and put it into position 1. So you just, in fact, you can see that here. This is, no, I'm moving from Y and putting into X, whereas up here I was removing X and putting into Y. So you can see my undos are pretty much the same. And so in part 2, I basically just say, hey, give me my input, reverse it, and then call the undo, which is like the opposite of apply, do that. So where was the struggle? Rotate letter. This one's really tough. And the problem is, if you think about it, you have a string that you've rotated some number of values. But where letter A is no longer, is not knowable, at least as far as I can tell. You know that A is currently in position 2, but you don't know where it was before because you don't know how many you rotated it, right? These rotates up here are super easy because you know the actual number of rotations you did, right? This one you don't know. Like, you can't just rotate left where position A is, because position A may be 2 at this point, whereas before it was position 5. So because of this math, the number is completely different, right? And I tried for the life of me to like figure out some kind of, can I figure out where, if it's now in position 2, where would it have been to have to get there? I just, it's possible I don't know enough about math. So the way I ended up solving it was, and this is where we get to like my actual solution that worked, was you basically just guess. There's only, 9 characters or whatever. 1, 2, 3, 4, 5, 6, 7, 8. There's only 8 characters. So the original position, could have only been in 8 places, right? Well, it's only been in one of 8 places, so let's just try it. And that's exactly what this does right here, is we say, okay, I'm going to guess, I'm going to create a guess where I rotate left. So I like reverse my position by that many spaces. And then I'm going to find where my letter is after that rotation. And then I'm going to see if me doing the math that I did up above puts me in the position that my current password is. So I hope I explained that right. Essentially what I'm doing is testing all 8 places. So if 3 is the right number, I'll rotate left 3, I'll find where my letter is, I'll do the math, and then I'll rotate right, and that will put me back where I am right now. So if my current password is the same as my guest password, I know I've found the right number of rotations to do. And so then I just rotate left that much because I was rotating right before. So I this is the one where I honestly don't know if there's a better way to do this, but this was my thing is I'm like, oh, there's only 8. So maybe I just try them all and see which ones. So that again, the effect is create a guess or a temporary, rotate it back to where it would be, and then based on that new guess, do the math and see if that would put us in our current position. And if it does, then we know that that's the reversal. That's the one that worked. So that's what that does here. Okay, so anyway, that's it. I think that was it. This could be a relatively short video, but I thought what I'd do because it all flailed and broke. And today wasn't actually that tough. Again, I think it took about an hour because at first I tried to like, can I infer the rotation? It's another one of those things where you have to say to yourself, oh, can I just brute force it? And in this case, I can because there's only 8, right? The total number of instructions are not large. Like this is on the order of 100. And the total number of guesses is 8. So even if all of them were all 8, all 100 instructions were rotate by letter, it'd only be like 8,000 checks in the worst case, right? And so that's one of those things where you say, oh, that's actually not that bad to solve the problem. And you can see it solves really fast. Again, most of the parsing is this input thing right here. So I think it solves relatively fast. Okay, so as we conclude and think about like what we can do to fix this, I wanted to try a couple things. This looks really ugly to me. I mean, I think it looks okay, but I'm wondering if there's like some way to clean this up. And part of me wonders if like the way to clean it up is to fix these like unwraps. We also do unwrapping here. And unwrapping here. I'm just wondering if we can, like the thing that's been going through my mind is, can we make it faster to code it if we have to worry less about unwrapping? And I used to do error handling, but I since got rid of it. Anyway, so those are the things that I'm thinking about. Like, for example, if I had main return a result of nothing, and then I just have this be okay. And then, for example, I could have part 2 be a result of string. So then I do like this. Like presumably that still builds, no issues. So I can do the same thing for this. I can also do it on parse input. So now the question is, how do I have this map return these? I think map will automatically turn them if I like specify. So if I say it's a result vec this, yeah, and so now I just have to have this parse return a result. Of instructions, and I can wrap this in okay, like that. So now I think I can do like oh, these character ones won't work. We'll have to figure those ones out. Okay, do you like the question mark operator there more than the unwrap? I think it's like technically fewer characters. I'm interested in like and it's like okay or else. Next okay, then you can just write next okay question mark. Combine with context. Uh, just do like okay or okay. I kind of like using anyhow, but can I just, what if I just delete this like this? Does it magically work? Oh, you had to do something like, it's probably not like that, huh? Let's go back to, like what I'm wondering, like it says static stir, but like that's okay. Um, is there a type I can use for the error type that would encompass all standard lib errors? Like is what I'm wondering. Oh yes, it's the Bockstein error thing, huh? Does that work for typing? Does. Okay, so you can potentially go, we ignore anyhow, and we change this to box error. Like those ones don't, these ones don't particularly feel faster than just unwrap. Again, because I have to like, I have to type all this out. Oh, I guess because it returns a thing, I don't have to do the okay here, is what probably what Clippy's saying. Yeah. I mean, that's definitely faster if you're doing it competitive. Like if you already have this type there, and you have like these things. I think for clarity, like just when I'm doing this, it's fine to do it this way. I'm curious, like, is there a better way to get the first / nth character from a stir? Then next unwrap. Yeah, well, we've talked about UTF-8 before because it's UTF-8. You know, the nth value in the array may be like mid character, but if you know you're using ASCII, you could potentially do this. That does work. I don't need Unicode code for most of this. It might be interesting to include macros. So like this would be x dot bytes 0 as car. Like, is that better? I don't need this, I guess. Yeah, like you can even see here, like this is not, this is like the longest, but this is like the most typical. This is what I was doing before. Probably okay. This is technically the fastest anyway. I could see having some helper functions. Like this one. And it's just like up here in like the, here's all the stuff I do. So we say like get car. So it's exact. So it's actually somewhat reasonable. Is that better? So like this versus these. I think if you were doing things competitively, this would definitely be nice. This feels a little weird though. Um, mm. I'll leave it like this, just as like a you know, something to like look at to see like which one I like, which one I don't. Okay. How do I have these return errors? These are the same, like position returns some or an option, right? Yeah. So you'd have to do something like this as well, or this. I don't know. The nice thing about Rust is you get the borrow checker and you get like the extreme, like, I don't know, type safety and stuff like that. um Sometimes you just want the answer, you know, this will always be the case, and so you're like, oh, I'm just gonna get it. And that's why if you look at like a Rust solution versus like a Python solution, the Python will usually be substantially smaller because you can just do things faster. And by faster, I mean like typing faster, fewer lines of code, right? Um, yeah, I don't know. Anyway, something to think about. You'll have to let me know what you think of macro rules. I do like this. I'd forgotten about the Bockstein error. Maybe I'll try and incorporate that. Um, yeah, I'm this one and this one are kind of interesting. It's like, do you just, is it easier just to do something? Maybe like think about it from a competitive or not competitive programming perspective. Anyway, something to think about. So let me know how you solved it. Sorry you couldn't see like the live solve. Um, Sometimes I wonder, is it even interesting to look at me stare at my screen? Um, uh, but it's definitely good for me because it makes me feel like, you know, I need to keep honest and how do I solve it and how do I do it correctly. Um, and explaining it helps because it makes me think about things. So, um, anyway, love that you're watching. Thanks for being here. And yeah, we'll talk to you next time. Bye, everybody.